Oh dear Lord.
B positive. Okay, we'll make it. Why are you jumping all over the place with these sections?
Well, here's the thing. The book goes 3-5 and then 3-6. The way they teach 3-5 is actually very difficult, but if you use this number line idea that I showed you here in 3-5, it actually makes it really easy. So what we're going to do is we're going to use those number line intervals to help me with my rational functions and how to graph them and all that fun stuff.
So when we do the homework, does it matter which, can we skip 3?
Nothing.
It's not going to matter.
You're not going to skip anything. You're not going to skip anything. So what is a rational function? Well, a rational function is written as P of x over Q of x, where P of x and Q of x are polynomials. What is the only restriction on this definition?
Q of x cannot equal 0.
Q of x cannot equal 0. Because if you have Q of x is equal to 0, then we're dividing by 0, therefore it's undefined and all that fun stuff. So that's just the definition of what it means to be a polynomial or a rational function. The base function, do you remember base functions? You know, what's the graph of x squared look like? It's a parabola. What's the graph of x cubed look like? A little squiggly. What's the graph of square root of x equal? It looks like this. And cube root of x, it looks like this and this going in the opposite directions. Well, there's a base function for the rational function. It's the easiest rational function going. And the base function is f of x is equal to 1 over x. That is the simplest of all rational functions. It is a polynomial over a polynomial. 1 by itself is actually a polynomial. X obviously is a polynomial. Okay, so what if I want to graph it? What do I do? Do you know what it looks like? No. So if you don't know what it looks like, how do you graph something? Yes, you can. Plug in a bunch of values, create a chart table. Create a table. So we're going to create a table. Actually, we're going to create 2 tables, but let's just start with the easy one. So we're going to pick a bunch of x values, and we're going to plug it into 1 over x. So we should choose negative, positives, and all that fun stuff. I would start with -3. If I take -3 and plug it into 1 over x, what do I get?
Negative 1/3.
Negative 1/3. These should be easy. -2 gives you negative 1/2. -1 gives you -1. 1 divided by -1. -1. If I take 0, undefined. That means 0 is not part of the domain of this function. It can't be because you can't divide by 0.
Why would you put it on there?
Because I need to talk about when is it undefined, because that becomes part of the graph. It does something to the graph. It does something. I mean, usually we have a graph and, you know, we have the x-axis and we have a graph that goes right through it perfectly fine. This one says, I can't have it here. So the behavior around that point is going to be strange. It's not just going to be an open circle. It's going to be really strange. All right, plug in 1, you get 1. Plug in 2, you get 1/2. Plug in 3, you get 1/3. Those are easy. So we can start graphing this a little bit. 1, 2, 3. 1, 2, 3. 1, 2, 1, 2, 3. Okay. To graph it, obviously, you plot the points we have. -3, -1/3. Where do I go? 3 to the left, and a tiny little bit down. -1/3. Be in the 3rd quadrant. And then you go to -2, -1/2, which comes down a little bit further here. And then you go to -1, -1, which is right about here. Now, I don't know what's going on between -1 and 0, so let's concentrate on -1 to -infinity. What happens as we pick bigger negative numbers, or smaller numbers negatively?
It's going to go
It's going to go higher and higher and higher, but does it ever touch the x-axis?
not quite.
No, it'll never ever touch it, but it'll get really, really
Close.
close. So this graph is going to go up as we go to the left, but it'll never ever cross that x-axis. So that becomes kind of special. So I'm going to put a little dotted line here. That blue graph will never ever reach the dotted line. But as you move to the left, it's always coming up a little bit. So it's always rising, but it never gets there.
And you will it not touch it because it's undefined?
No, it's defined perfectly fine. It's just that if you take 1 and divide it by more numbers, you'll never get to 0. 1 divided by 100, 1 divided by 1,000, 1 divided by 1,000,000, 1 divided by 1,000,000,000,000, 1 divided by whatever number you want to choose. It's never ever going to equal exactly, but it'll be really, really close. Really close. All right, the same thing happens on the other side, except on the positive version of it. At 1, you're at 1. At 2, you're at a half. At 3, you're at a third. And as we go to the right, this graph is going to come down, come down, come down, but never ever touch that x-axis. So this x-axis has a special name in this case. Because the graph is approaching it as we go to positive and negative infinity, we're going to call it a horizontal asymptote.
What?
Asymptote. Did you say untouchable? Misconception. You can touch a horizontal asymptote. I'll give you an example later. I have several examples with it touching it. The asymptote.
Did you make that up?
No.
That word?
Asymptote is somehow how people pronounce it. Asymptote. What an asymptote is as you go to positive and negative infinity, the graph has to approach this line, this horizontal line. It doesn't say that it can't touch it. It just says that as you go to infinity, it actually gets so close to that line you can't tell the difference. You can't tell the difference. All right, so that leaves me one problem. What's happening between -1 and +1? We don't know, so we got to go find out. And how do I find out? You set up a table. You set up a table. And you choose values that are between -1 and 0, and 0 and +1. So pick a value between 1 and 0. -1 and 0, I'm sorry, -1 and 0. -1/2. So if I take -1/2, and I think this is supposed to be x, and I plug it into 1 over x, this becomes 1 over -1/2. What is 1 over -1/2? Don't you dare touch a calculator. How do you divide by a fraction?
1 divided by.
How do you divide by a fraction? Multiply by its
Denominator.
reciprocal. And the reciprocal of -1/2 is?
2.
-2. So 1 over -1/2 is -2. All right? -1/3.
-3.
-3. -1/10.
-10.
-10. Okay.
Alright, we got it.
Now, if I go +1/2, that's of course 2, and +1/3, that's going to be 3, and +1/10, that's going to be 10. All right, let's plot those points as best we can.
Where did
Create the graph.
never mind.
I'm picking values between -1 and 0, and 0 and +1. So if I go to 1/2, which is here, you have to go down to 2. If I go to -1/3, which is right about here, we're going down to -3. Same thing on this side. At half, you're going to 2. At a third, you're going to 3. The 1/10 goes to 10. Where would 1/100th go? 100. 1,000? 1,000. It's always going to be the opposite. So as we get closer and closer to 0, as we squeeze in on these values here, where are my points going?
They're not going to touch.
They're going to go way down or way
They're
up.
not going to touch the wire.
And it's not going to touch the
So it's
y-axis.
that funny little thing you've been tickling about stuff.
That you can't divide by 0 because one goes up and the other one goes down, and it makes no sense. Okay, but this also tells you you cannot touch the y-axis because it has this value that we're considered undefined. So that creates this little line. And this little line is actually more important than the horizontal asymptote. This one is called vertical asymptote. Asymptotes.
Isn't that like a kid?
Now,
History word?
asymptote? I don't know.
Asymptote.
I don't know. Horizontal lines, horizontal asymptotes can be crossed. They can be crossed. Vertical asymptotes cannot be crossed. because they would create a point of undefinedness, and we can't do that. So vertical asymptotes are very rigid. You cannot cross them.
But you can't cross horizontal.
You can cross a horizontal one, which makes it interesting. And we don't have much more time, so let me show you what I mean by you can cross it many times. There is a graph out there that looks like this, has a horizontal asymptote at some y equals k value. You don't have to write this down.
We're not.
The graph starts here, and it does this. It crosses the horizontal asymptote an infinite number of times, but as you move to the right, the graph gets lower and lower and lower and hugs the line top and bottom. So as long as it approaches it from both directions,
But it never turns to a straight line.
well, it doesn't, it touches it an infinite number of times.
But does it ever turn to a
Iteration of
3-5?
3, 5. Start. There it is. All right, so continue 3, 5. We left off with the base function f of x equals 1 over x, and the picture we got out of it, after doing a nice little ugly table, was something that looks like,
The
oops,
little L's that don't touch the line. Yeah.
looks like this. Little L's, that's an interesting way of looking at it. And we talked about how the x-axis in this case was called the horizontal asymptote, and how the y-axis was the vertical asymptote.
All right.
And we also talked about how horizontal asymptotes really don't mean that it doesn't cross it. It's just as you go off to positive and negative infinity, the graph gets pulled in. Now, asymptotes are basically, when you're graphing with them, they become like magnets. They pull the graph in towards them. All right, so a little more notation about this. Talking about the horizontal asymptote, it's actually defined by this thing called a limit. And it's abbreviated LIM. This is just in case you ever go to calculus.
What is this now?
I'll
Limit.
take it out of here.
Now, a limit just tells you what a graph approaches. It doesn't say what it's equal to. It just says, I'm really getting close to some certain number. Then you say what x is going towards. So the first one we're going to go towards is infinity. So as x goes off to larger and larger values forever and ever, what is this graph approaching? Well, I'll have to tell you what graph we're talking about. We're talking about the base graph 1 over x. So as x gets bigger and bigger and bigger, what value are we getting closer to?
1 over x.
Yeah, but as 1 over x gets, as the x gets bigger, you're going to 1 over 10, 1 over 100, 1 over a billion.
Or you get to 1.
1 over a billion is closer to 1? Now, come on, we talked about this last class.
Yeah.
What's 1 over 10 equal to, decimally?
0.5.
Heart attack, oh my god.
0.5.
That's 1/2. 0.1, what's 1 over 100? 0.01, what's 1 over 1,000? 0.001, what's 1 over a billion? 0.0000001, what's it getting closer to? 0. So this is defined to be getting closer to 0. It never gets there. It never ever gets there because 1 over a number is always going to give you some kind of value. It's just as x goes off to huge numbers, this thing becomes what's called insignificant. It's like giving $1 to Donald Trump. Is he going to jump up and down for joy?
You might.
No, he won't. It's like a penny to you. Actually, it's worse than that. It's like 1/10 of a penny to you. Probably worse than that. It's probably like 1/1000th of a penny to you. All right, so what we're going to say is as x gets really, really big, positive infinity or negative infinity, the graph is approaching so close to the x-axis that you couldn't tell the difference. It's getting really, really close to 0. The other limit of interest here is what happens as x approaches 0. Now we have a problem with this. If x approaches 0 of 1 over x, it actually does two different things. For instance, if you come in from the left, approaching 0 would be approaching the origin. What happens to the graph as you approach it from the left?
It goes away.
No, it doesn't go away. You have to follow the graph. Where does it go?
It's gonna go down.
How far?
Until infinity.
Negative infinity, because it's going down, right? So if we approach from the left, it's going to negative infinity. If we approach it from the right-hand side, where's it going?
Positive.
Positive infinity. I can't give that an answer because it's two different answers, which is another reason you can't divide by 0 because it gives you those two different. We talked about that in the very beginning of class.
Oh, yes.
So what we're going to do is we're going to distinguish it. We're going to put this little minus sign after the 0. After the 0, not before the 0. That just means from the left. You're going to come in from the left side of the graph to that value of 0. Now, if we're coming in from the left, we talked about how the graph is going down forever. So we're going to call that negative infinity. The graph is going to negative infinity as we come in from the left.
Okay, so when it comes in from the left, you put the negative on the 0 on the right.
On the right-hand side, that little negative just means it's coming in from the negative side. Now, if I write this, limit as x approaches 0, and I put a little plus sign behind it, that means it's coming in from the positive side, or the right-hand side. And that answer, we were talking about earlier, is equal to positive infinity. And the two of these together actually define why you can't divide by 0, which is another way of looking at it. All right, so horizontal asymptotes always have this fact. The reason that this is a horizontal asymptote, y equals 0, horizontal asymptote, is because it's what the graph does as x goes off to infinity. So is the horizontal asymptote always going to equal 0?
Not necessarily.
Not necessarily, and that's where it gets fun. Okay, so while we're here, let's do this graph. How would I graph that? Ooh, what happened? This thing's not working very well today. Okay, new marker. How do you think we would graph this? That is so weird. What does it look like?
It's going to go, no.
Go ahead, say it.
I was going to say, does it go off to negative infinity?
No,
Or negative, no.
Think of it. This is a base graph, 1 over x. This is what the picture looks like. What does this do to the base graph?
But it shifts to
It flips it because of the negative.
And we're gonna go to the left twice.
It'll go left twice.
I see.
And then we're gonna go up 3.
And up 3. It's a transformation.
Yeah.
So, up 3, left 2, and flip. Over the x-axis, or over the horizontal, depending on which one you want to do first. Alright, so if I'm going to graph this, I need to go up 3, I need to go left 2, I need reference lines. You really need it for this one. Because these reference lines become your horizontal and your vertical asymptotes. Oh, by the way, what can x not equal here?
-2.
Negative 2.
Oh,
It can't be this vertical asymptote. So whatever the bottom cannot equal becomes a vertical asymptote. It's a neat little thing. Alright, now what is the picture going to look like? I've moved it to the right location.
Give me a second.
It's going to look like this picture, but it's going to get flipped. So it's going to be high on the left and low on the right. And you just put it in here. So it goes right here. High on the left, low on the right.
Now, where did you determine that?
Because
It's usually low, high.
Right?
It's getting
You
flipped.
it. Okay.
So it becomes high, low.
Gotcha.
What's really cool, well, actually what's really cool about this is what's considered an odd function. So it doesn't matter if you flip over the x-axis or if you flip over the y-axis, it comes out exactly the same. Yeah. But that would be the picture of it.
alright, so you wouldn't want precise, you don't want a precise spot of location.
Well, there is, well, I mean,
More of
there's
a
some
sketch.
precise spots, but I'm just looking for a generalized
Cool.
picture. I mean, we could find the X
No.
Intercept if you want.
No, that's okay.
So let me ask a silly question. What is the limit as x approaches -2 from the left of this function g of x?
What is the limit?
What is the limit as x approaches -2? That's how you read all this funny stuff here. From the left, this little minus sign, from the left. So you come in, you start way over here at negative infinity, and you move through this graph. And as you approach -2, where's the graph going?
On positive infinity.
Going to positive infinity. So the answer here would be, if you want to be really precise,
Okay.
positive infinity. All right. And then what would be the limit as x approaches infinity of this function g of x?
-2.
Nope. Infinity is this way. What's getting closer and closer to?
0.
No.
You said going that way?
As you follow the graph going to
Oh,
positive
okay.
infinity, what is it approaching?
3. Sorry.
What is it approaching?
Is it 3?
3.
I'm
The
sorry.
horizontal asymptote.
Yeah.
The horizontal asymptote. So as the graph goes off to positive infinity, it's getting closer and closer to this dotted line, which has an equation of y equals 3. Okay. Of course, that's simplistic. You think I'll have that on the test?
I doubt it.
Heck no. Just trying to get you used to some ideas.
If you was just to put that on the test, no problem. Half was simply.
That's a scarier part.
So the three in that answer is actually
The horizontal asymptote. Yeah, the limit off to infinity is always going to be the horizontal asymptote. We're going to use that fact quite a lot. All right. How about, let's see, the simple one. This one. For example, let's graph in its entirety this function f of x is equal to 4x plus 3 all divided by x squared minus 4x plus 3. Now, just like graphing parabolas, where we found the vertex and the axis symmetry and the x intercepts and the y intercepts, this has some similar features. But the features are going to be slightly different. We're going to be looking for vertical asymptotes, and we're going to be looking for horizontal asymptotes, and x intercepts, and y intercepts, and some other points. So when I start these off, I usually start with the asymptotes to get them out of the way because they're usually the weird part of it. And then x-intercepts and y-intercepts are just natural. They should be natural to you by now because we've done them so often. So let's start off with the easy one, I think. How do you find a vertical asymptote? What caused the vertical asymptotes for my 1 over x and that other one we just did, the 3 minus 1 over x plus 2? What caused that vertical asymptote? With 1 over x, what can x not equal? The bottom cannot equal 0. So when you're looking for vertical asymptotes, you're looking for the denominator, and you're going to set it equal to 0. Because it can't. And this is what's going to force your graph to have these vertical asymptotes. So you take the bottom, and you set it equal to 0. You don't even have to worry about the top. The top doesn't help you find these undefined values. So set it equal to 0. How do you solve this equation? You stare at it. The answers will just come to you. Now, you could complete the square, but always try something first. Try to factor. I'm hoping it does. Factors of 3 that add up to 4. 3 and 1. So it's x minus 3, x minus 1. Therefore, your vertical asymptotes are going to have an equation of x equals and x equals. Now, these are values. This is probably the only time that I'll say, oh, we have these x values. Should we go looking for our y values? You can try, but what's going to happen? You're going to get 0 in the bottom, and you're not going to get any because it'll be undefined. So this is one case where you find some x's, and I'm not really going to ask you to go find the y's. This is really the only case that it shows up in. So these become nice little dotted lines on your graph, and the graph is going to approach them, but never ever touch them. Okay, so that'll become important. Next one up is horizontal asymptote, and nobody likes finding these. The book has a shortcut, but the shortcut becomes kind of dangerous if you use it wrong. So I'm going to show you the long way of doing it, and if you want to use the shortcut, great. But at least the long way will get you the right answers every time. We're going to use the fact that if we send x off to infinity of f of x, and we can find some number k that it's equal to, then our horizontal asymptote is going to have an equation of y equals k. It says, let x go off to really, really big. Is it approaching a single value? All right, so I'm going to set it up as the limit, as x gets really big, of my function. Now, the part I need to use is that limit of 1 over x going to 0. But there is no 1 over x in this function. So what I have to do is kind of force the issue a little bit. And to force the issue, you're going to rewrite the original function as a bunch of little fractions.
Oh boy. Where's that to?
So you write it as a bunch of little fractions. And the trick is, you're going to divide by the highest power of x that you see in the entire rational function. So what's the highest power of x that you see?
Squared.
X squared. So you divide every single thing by x squared. Is this legal?
Apparently so.
Why though?
You said something.
It's a fraction, and whatever you do to the top, you can do to the
Bottom.
bottom. You have to balance it off. So this is a totally legal step, and what it does is it forces that something over x notation, which I need.
So something cancels out.
Well, a bunch of x's are going to cancel out, hopefully. So this becomes the limit. As x gets really, really big, 4 over x squared reduces to 4 over x. 3 over x squared isn't going anywhere. X squared over x squared is 1. Negative 4 over x plus 3 over x squared. All right. Now you have to use your imaginations. We were talking about 1 over x, and if x got bigger and bigger and bigger, that it was approaching 0. What do you think is happening to 4 over x, 3 over x squared, 4 over x, and 3 over x squared? They're getting smaller. How small? Really, really, really small. So do they add anything to my answer?
Not really.
Not really. So each and every one of them that has an x in the bottom is going to be doing what's called approaching 0. This is how my calculus teacher used to do it.
Oh,
The little arrows through, and they're all approaching 0. So what's left in the top if the top is approaching 0?
Not 0.
0. For limit purposes, it might not get there, but you can say that it's equal to 0. What's in the bottom?
Only one is a
1. And 0 divided by 1 is?
0.
0. It gives us an answer. That's really important because if you got 0 over 0, something's wrong. Or if you got 1 over 0, something else is happening there. But here, this is perfectly fine. 0 divided by 1 is really 0. So we have a horizontal asymptote, which is y equals 0. The graph is going to approach the x-axis. It might touch it, it might not. It might touch it, it might not. Now this step, there is a shortcut again, but if you use it, you got to be really, really careful. So this is just the long way of doing it. And it'll guarantee you get
It's
you
going
right.
to be right every time doing
It's going to be right every time.
All right.
And if something funny happens, like if you end up with 4 over 0, it's not what I'm going to show you how to do. It's a slant asymptote, but it gets really fun.
Okay.
But yeah, this one will give you the right answer every time.
Where's the k at?
What, k? In this case, k is equal to 0. K is just some number. It could be anything. That's what we're looking for, though. Problem. The graph can cross the horizontal asymptote. So here I'm telling you that y is equal to 0. Guess what you should go look for?
0 on the y. The
If I tell you what y is equal to, you go look for x. The only time you don't do it is vertical asymptotes. That's the only time I'll never have you do that. So here I'm telling you, oh, y is equal to 0. So I'm going to set the whole function equal to 0. What happens when you set a function equal to 0? What are we really looking for? No. When you take a function and you set it equal to 0, what are we looking for? X intercepts. So this step here, even though we're taking the horizontal asymptote and we're setting the function equal to it, this is really finding the X intercept. So it's actually one of our steps, which is kind of nice. Does this happen all the time? Yeah.
Probably not.
No, because it's not always equal to 0. All right, how do I solve this equation? Okay, staring at it again.
I'm still writing.
Multiply by, no, common denominator. What's the common denominator?
Let's factor it out.
This thing.
That whole thing?
So if I multiply by that thing on both sides, what happens to that thing?
It counts.
It goes poof.
That is the proper way to do
0
it.
times anything is, well, 0. So this is equal to 4x plus 3. That's easy to solve. X is equal to negative 3/4. If you multiply both sides by the denominator, over here they will cancel. And anything times 0 is 0. And then it's a nice linear equation. But this is a coordinate. It has negative 3/4 for the x value. What's the y value? 0. So this graph actually does cross the horizontal asymptote because it has an x intercept in this case. Okay. What else can we find besides x intercepts? Y intercept. So y intercept, here you're going to let x equal 0. So we're going to evaluate f of 0. Now, if you evaluate f of 0, what happens? And all the x terms will go bye-bye. So what's left in the top?
3.
No, 3. What's left in the bottom?
3.
3, and 3 over 3 is 1. So you get this coordinate 0, 1 is your y-intercept.
And
Almost
I'll
done.
write down real quick how I got this, because I'm not going to have it.
Where did you pull that F?
0, 0, 0.
Huh?
3 over 3. F of x.
Okay.
Plug in 0 for x. 4 times 0 is 0. 0 plus 3 is 3. 0 squared is 0. Minus 4 times 0,
Yeah,
which is
I
0.
got that, but where did
3 over... What do you mean?
You gotta say it.
To find it...
where did you pull that x equals 0 all of a sudden from?
That's how you find the right.
Okay.
That's how you always find a y-intercept. You let x equal 0.
Oh yeah. All right. Thank you.
Is it a Monday? It seems like it. Okay. So we have x-intercepts, we have y-intercepts, we have horizontal asymptotes, we have our vertical asymptote. Next step up is that number line thing I was showing you last week. The number line thing is actually more important than all the rest of it. Though you do need the asymptotes definitely to make this work right. The number line thing is going to tell you when the graph is above the x-axis and when it's below. That's really, really important. The book doesn't do this, by the way. They do it a harder way. Number line makes it a little bit easier. So the number line thing is the numbers you're going to put on it. They're not necessarily zeros of the function. They're values that make it 0 on the top or the bottom. Even though the bottom can't equal 0, those are still what's called, we'll call them critical values. So we'll set up a number line. And the numbers we're going to put on it are anything that make the top or the bottom equal to 0. Well, what makes the top equal to 0? Negative 3/4. It makes the top equal 0. So one of the numbers I'm going to throw on here, I'll put it right, hold on. Yeah, I'll put it right here. Negative 3/4. What makes the bottom equal to 0? We've already answered all of these questions. What makes the bottom equal to 0?
0.
No.
Oh, 3 and 1.
3 and 1, the vertical asymptotes. So we've already answered them. We found the x-intercepts, that makes the top equal to 0. We found the vertical asymptotes, that makes the bottom equal to 0. So you just need to take those two pieces of information and put them over here. 3 and... Oh, shoot, I put it in the wrong order. This should be 1. 1 and 3. Okay. And from last week, we just tested numbers in these intervals. So what's a number smaller than negative 3/4?
Wow. Negative 1.
0 is not smaller than negative 3/4.
Negative 1.
Negative 1 half?
Oh, no.
Did you say negative 1 half?
I did. I'm sorry.
How about negative 1? Negative 1 half is between negative 3/4 and 0. If you take negative 1 and you plug it into your function. Oh. I'm not sure if I want to go back and plug it into the original function. You can. You can. I'm going to leave it in factored form. That's the best way. So I'll rewrite it over here. The top is 4x plus 3. The bottom is x minus 3, x minus 1. All right. If we plug in -1 into this function, what happens at the top? Is it positive or negative?
Negative.
Negative. So the top becomes negative. What happens to the bottom? -1 minus 3 is, we had this discussion last week, don't you remember? And -1 minus 1 is also going to be negative. So we get 2 negatives here. So if I put all 3 of these negatives together, what do I get? Which is a negative. Triple negative. All right, pick a number between -3/4 and 1. 0. 0 is always a nice one. The top becomes positive. The bottom becomes both of them negative. And positive, negative, negative is positive. Even number of negatives is positive. Between 1 and 3.
1.5.
Oh, stop it. 2. Yeah, I guess you could do 1.5 if you feel like it. The top becomes positive. The first one becomes negative. The second one becomes 2 minus 1, positive. All right, positive, negative, positive.
Negative.
It's negative, below the x-axis. Pick a number bigger than 3.
8,000.
You can do that too. But I'm going to choose 4. And if you put it in, you get positive, positive, and positive. So this one becomes positive.
Said it
Don't
doesn't
worry
matter.
about your
We'll
sign
hit it off
back
to
there.
infinity. Said it doesn't matter. We'll hit it
As
off
long
to
as you pick a number bigger than
You
3 in this
said
case.
you get positive, positive, and positive?
Yeah.
Okay.
4 times 3, 4 minus 3, and 4 minus 1. They're all positive. If you want 1,000, 1,000, 1,000, it's guaranteed to be positive. All right, so now the graph is below the x-axis, below -3/4. Between -3/4 and 1, it is above the x-axis. Between 1 and 3, it's below, and above 3, it's above. It tells us kind of where the graph has to go. And then these asymptotes start squeezing it into certain parts of your picture, and you have no choices but to draw where, it's legal. So let's put in a few pieces of information. Let's see if this one's working.
No.
And let's see, biggest number, 3. So 1, 2, 3, 4, 5. 1, 2, 5. 1, 2, 2, 5. It's hard to find graphs that fit in a nice little location. They usually go a little crazy. All right, information that we want to put into this graph. Well, it's got vertical asymptotes at x equals 3, so we get this vertical line at x equals 3. We also get one at x equals 1.
That's not fun.
Yeah, that's all right. And we have a horizontal asymptote. Now this one's hard to draw
You know, squares it in this little tiny
because it is the x-axis. So what I usually do is I just show dotted lines at the ends of the axis to remind me that that's the horizontal asymptote. Okay. So we got our horizontal asymptote at y equals 0. Vertical asymptotes at 1 and
be able to form.
what?
The horizon.
Okay, the vertical asymptotes are 3 and 1.
3 and 1. The horizontal asymptote is y equals 0,
Okay.
which is the x-axis.
All right, I'm following you so far.
Okay.
So
Plot our-
now,
Plot points that we have. Let's see, what points do we have? We have -3/4, 0. Oops, wrong way. That's over here. -3/4, 0 is right about here.
Okay, sure.
I don't know. I usually plot points badly. 1, 0, I'm sorry, 0, 1 is the y-intercept. That's right here. I think that's all the points we have.
where,
We don't have it all.
-3/4, 0, 0, 1, 0, 1. The rest of the graph is going to come from above and below. And realizing that the graph is going to be pulled into these asymptotes like magnets. All right, so the first part of it, from -infinity to this point, right here, this first point, the graph has to be
Below.
below the x-axis. but it also has to approach the x-axis. So how am I going to do that? So I know my graph is going to be coming down like that, but if it's going to approach the x-axis, it's going to eventually have to be pulled back up. So it's going to have a little bubble effect. In a graphing calculator, you would never see this bubble effect. It would never show up. But sketching-wise, you can show it, and it's going to curve back and approach the asymptote, the horizontal asymptote. It's the only option for it. All right, so between -3/4 and -infinity, it's below the x-axis, and it has to approach the horizontal asymptote. So you get a cool-looking picture like that. Like I said, though, on a graphing calculator or a graphing program, you would never ever see this bump unless you zoomed up in on it a lot. All right, between -3/4 and +1, this first vertical asymptote. So between -3/4 and +1, it has to be positive, has to go through this point. And as it approaches this vertical asymptote, where is it going to go? You only have two options, up and down, but it can't go down. So the only option you get is straight up. Okay. So that gives me my left part now. The middle part is a little harder. Between -3/4 and 1, I'm sorry, between 1 and 3, between these two vertical asymptotes, it has to stay below. I don't have any points. So what I'm going to do is kind of guesstimate what it's doing. If it goes, it can't go up these vertical asymptotes, right? So the only option is to go down this one and down this one. How do you think we're going to connect those? Straight line? Parabola-looking thing?
Sure.
More than likely parabola-looking thing. Now, the problem with this piece is I don't know how low it is. So this part of it is literally a sketch of the graph. I don't know how low it is. I don't know how close to the x-axis it is, but I know it can't go above it. It has to stay below. So you get a little U-shaped here.
I can't.
What other option am I going to have? It has
No,
to
you're
be
right. No, I'm fine. I mean, I get it. But
It has to be a
I
smooth
don't get
curve.
it.
I know it's going down on both sides here because the asymptotes say that the graph is going to pull towards them. I just have to connect it with something. And this U-shape is not necessarily always going to be U-shaped. I have seen these graphs look like this.
The only reason it's U-shaped is because you've got those two exit or
The vertical asymptotes. It's forcing both of them to go down,
instead of
and they
doing
have to
outlet,
connect
instead
somehow.
of doing like this because now if you'd only had the one vertical asymptote,
Then it would just go down, and you
but
wouldn't
it
get the
still,
shape.
but it would still would it still follow your horizontal?
Oh, over here? Yeah.
Yeah.
Yeah, you'd get this L shape.
So because it's got a second vertical, it
The L shape
dictates where you're.
Oh gosh, everything dictates where it's going. Below the x-axis, can't touch these vertical asymptotes. It pulls in like magnets, and they have to stay down. It can't go up, because if you go up, what are you crossing?
Right.
The x-axis,
I
and you
get, I,
can't.
I just,
Okay. All right, bigger than 3. Where am I? Well, I'm positive, so I'm above. I only have one place to put this picture, and it has to go in this top right-hand corner. And it has to approach the vertical asymptote, and it has to approach the horizontal, so the only shape I get here is something that looks like this. And that would be the graph of f of x.
and why does it have 3 separate ones?
Because you have 2 vertical asymptotes. It can't cross either of them, so it splits the graph into 3 equal pieces, or 3 pieces.
Hey, can you give us another one?
Oh gosh, yeah.
Randomly generated from your
Oh,
book?
that's what I'm pulling it from.
What are your summer classes?
Huh? What are my summer classes? 6 to 8:30,
Oh, so
Monday
you
and
finally,
Wednesday.
He came over with us.
I mean, this is gonna ruin my whole
It's not, it
everything.
is not.
Practice. It's just practice.
It's
It's the
not
same.
just this, the whole
Oh,
section. The whole section.
it's still practice.
6 to what? 8:30 what
6
day?
to 8:30, Monday, Wednesday.
I
You'll
think
see
I signed
angry
up
people right after getting off
I
work.
think I
Smell like
signed-
Coca-Cola. Sorry, though.
because I really picked up another job and I've already got my hours set, but I hate to renege go off and be out of a job.
But don't read it.
Yeah,
It
no,
from 6
it
to 8:30.
is.
We'll
No,
be
I
good to
got it.
go.
I
Upset.
got it.
But we're gonna get it right this time. Somehow.
I gotta take this because I'm just running in place in my career. I'm trying to advance.
That's not funny at all. Wait.
I'm always running in place.
Really?
Where am I going to advance to? I'm the highest I'm
Yeah,
gonna
you
You're
get.
the
are.
highest you're at, and that's what I'm trying to get to, the highest I can get to, but
Are you saying you're comfortable, Mr. Kalora? You know, just something more you can
Do
find
I
out
enjoy torturing you all?
Of course you do. I
Heck
mean,
yeah. I would not want to be an administrator. That's the next thing up. And, ugh,
that's just, you
No.
wouldn't get a chance to torture us, huh?
I wouldn't get a chance to torture. I'd get to
You
torture
can torture
faculty.
somebody.
I could torture faculty.
Yeah, they're
Why
not
don't you
as
go
fun
do
though.
it?
Nah, don't do that.
and then they'll take it
Get
out
away
on
from the
us.
students.
Don't do that.
All right.
They'll take it out on us.
So if we want to graph this, it is the exact same steps. Vertical asymptotes, horizontal asymptotes. Does the graph cross the horizontal asymptotes? X intercepts, Y intercepts, and the number line.
Alright, so step one, we're factoring out that bottom half and we're gonna get 5 or 2.
Well, no, actually, do that step thing again.
The step things are vertical
Step
asymptote.
Slowly.
Here, watch. It'll be
No,
slowly.
I don't want to watch.
One. Vertical. That's why I underlined all these things. Asymptote.
Or factor the denominator.
Take the bottom, set it equal to 0. Because,
Wouldn't me.
wasn't me.
All right, hold on a minute.
You can pull these off later. Vertical asymptote, take the bottom, set it equal to 0. Are there factors of 10 that add up to 7?
Yes.
2 and 5, so this would be x minus 2, x minus 5. And it's equal to 0. So we get x is equal to 2, x is equal to 5. Yes, you should be able to do it that quickly.
Yes. Step 2.
This is stuff that we've learned a long time ago, how to solve a quadratic equation. Alright, so these become our vertical asymptotes. We don't need to go find y for these two because they don't work. They cause, undefinedness. Step 2, the horizontal.
Or
Maybe I should write that.
find the X intercept.
What, do I write this down for my help? Jeez. Maybe I should write this down. Possibly. The horizontal asymptote, you take your whole original function and you say, oh, the limit as x gets really big.
We're not doing all that.
Okay, what's the answer?
I want you to do
I
all
don't know.
that.
I'm going to divide it by the highest power thing.
What's the highest power?
X squared.
Square.
So, it should be minus 7x, but it really doesn't matter. Plus 3, all divided by x squared, divided by something minus 7x, divided by something plus 10, divided by something. And the highest power in this case is x squared. So x squared, x squared, x squared, x squared, x squared, x squared. Sometimes people can answer it right from here.
Of course they can.
Anything that leaves an x in the bottom, ignore. Anything that leaves a number, keep. So which ones do we keep?
1.
In the bottom?
Yep.
What do I keep in the top?
Nothing.
Yes, we do. X squared divided by x squared
again.
is?
Oh, 4.
It'll be 4. So it'll be 4 in the top and...
Oh no, you're skipping a step.
Oh,
there.
all right. Limit
You can't do that. Not yet. Not yet, man. You can't do that yet.
infinity. You get 4 minus 7 over x plus 3 over x squared, all divided by 1 minus 7 over x plus 10 over x squared. Anything with an x left in the bottom goes poof. It gets really, really insignificant. And we're left with a 4 in the top and a 1 in the bottom, which is 4 over 1, better known as 4. So our horizontal asymptote is going to have an equation of y equals 4.
Okay, so all those.
You forgot to do the line 0.
Oh, I-
No. Yeah. Come on. Do it.
I said you can't skip steps yet, man. It's too soon. Thank you. Thank you.
Approaching, gotcha.
Approaching 0. Getting really, really close. Becoming insignificant.
See, we with you. It's just that we're behind you. We're here, but
We're here.
I
Alright.
don't know how we
Now,
got here.
where x equals 2 and x equals 5, we didn't go looking for the y value. Here I'm telling you y is equal to 4. You better go find if it actually has an associated x value. It might not. It might not. But most of the ones I try to create do. So we're going to go up here, and we're going to take the original function and set it equal to 4.
Is this still step 2?
It's part of step 2. Find out if it crosses the horizontal asymptote. But usually if you find a value, you should find its corresponding x or y value. Like I said, we don't do it here with the x's because they make the bottom undefined. But here I'm finding y is equal to 4. Are you not curious what x is equal to?
Not really.
I am. I'm always curious about that. I've been telling you to find these things all the time through this entire semester.
No, it's not the X, it's the Y, I don't care.
So, how do I solve this equation? What do I do first?
You multiply everything by the denominator.
Alright. So basically all that happens is this thing multiplies that side. It just multiplies it. So you're going to get 4 times x squared, 4 times negative 7x, and 4 times positive 10 is equal to the numerator, which is 4x squared minus 7x plus 3. I guess you could think of it as cross-multiplying if you want.
You actually using that term?
It only works if you have a fraction equal to a fraction, and you can set this as a fraction as 4 over 1. But I don't like using it because people misuse it horribly.
How did you?
What? You multiply both sides?
No, I looked down on the page to write something down, I looked up and you got something else written up there, I have no idea how you got it there.
What?
The second half of that.
Where?
You got 4x squared minus 28x
Yeah.
plus 40.
Because I multiply the bottom over here.
Okay.
This is the top.
Alright.
That's just the top. What happens to the 4x squares?
They can't.
They cancel rather nicely. They're both positive and they're on opposite sides of the equation. So how do I solve for x?
So this gonna be -7 plus 28,
Alright, so that gives you
21x.
21x on this side.
And then that's gonna be 3 minus 40, which is -37.
Positive 37 on this side.
How?
Because you're only subtracting 3.
You move the 28 to the right, you move then the 3 to the left, and 40 is bigger. Careful with your signs, and don't depend on your calculator too much. So we get x is equal to this beautiful number, 37 over 21. Now 37 over 21 is equal to what decimally? Because I can't plot that, I don't know where to plot that.
37 over 21 is equal to 1.76.
So 1.8?
1.8.
1.8. So we found this coordinate, we're going to just plot it as 1.8 comma 4. This is the only time, this is what's nice about finding this. This is the only time the horizontal asymptote gets crossed. It only gets crossed once. So that means it cannot cross it ever again. It crosses it at one coordinate. Okay, so we have vertical asymptotes, we have the horizontal asymptote and its associated point. Next up.
Instead of 3, it's the number line.
No, it is not.
Hey,
Oh, we gotta get our X intercept.
X intercepts. To find an X intercept, you set y equal to
0.
0, or the function equal to 0. So that becomes 0 equals 4x squared minus 7x plus 3, excuse me, divided by x squared minus 7x plus 10. How do I solve that equation? I've already done it like twice. How do I solve that equation? What? Let y equals 0, the function becomes equal to 0, and you get the other half. So how do you solve that? Okay, come back up here. How did we solve it when we set it equal to 4? Multiply by the denominator. What do you think you're going to do here? Multiply by the denominator, or cross multiply if you want. 0 over 1, cross multiply.
Right.
We'll cross multiply this time. So we're going to get 4x squared minus 7x plus 3, and it's going to equal
0.
0, because anything times 0 is going to give you 0.
Hey.
What? Hey, is for horses, as my mom used to
Go
say.
up a little bit. I'm stuck on the equation. 4x squared minus 28x plus 4 equals 7. Okay. Where you get that 37 from?
Subtract 3 from both sides.
He didn't draw it.
Oh, I don't show linear
No.
equations. 40 minus 3. And
What you gotta do to one side, you gotta do
28
the other.
minus 7.
Those old school.
Oh.
Old school
I'm
stuff.
saying like, look now.
We're falling apart as you can see.
I
and
see.
we need your help.
Over simple things that we should know how to do already.
But we're still falling
I
apart.
know. You're solving a linear equation. Get the x's on one side, get the numbers on the other. Ah. I know it's been a while. Okay, how do I solve this equation down here? 4x squared minus 7x plus 3 equals 0.
Let's subtract 3 from it.
Well, I always try to factor.
Oh, okay.
Ooh, factor.
But
Factor. If you subtract 3, it's not going to help you.
3 and 4,
It's not going to help you.
Alright.
So factors of
12,
12 that add up to
7, 3 and 4.
3 and 4. This one actually factors, which I was surprised by.
I got you.
So you get 4x squared minus 3x minus 4x plus 3. You remember this pulling apart and grouping and factoring and all this fun. Maybe you don't remember this pulling apart and grouping.
I do.
Yeah.
Okay.
Factors of 12 that add up to 7 are 3 and 4.
Well, wouldn't it be
They're both
easier-
negative because I need them to add up to negative
wouldn't it
7.
be- Don't you want to rearrange this?
Why?
Because I do.
Oh, well, you go right ahead. If I pull out the GCF of the first two, what do I get? X, what's left behind?
4x minus 3.
What's the GCF of the second two?
Negative 1.
Negative 1 left behind is 4x minus 3. So we get 4x minus 3 and x minus 1, and we want to set it equal to 0. So that gives me coordinates. What are the two coordinates?
1
1 comma,
and 3, 4.
1 comma,
comma,
1 comma,
1 comma.
0.
0. And 3/4 comma, 0, because these are what?
Those are y.
Intercepts.
X intercepts. And we let
Whew.
y equals 0. Therefore, they have a y coordinate of 0.
My son is doing this in school.
Is it?
He's in the 8th grade.
Good for him.
This,
All these little pieces that he needs so he can deal with
It's
this job.
hard. It's
you can
hard.
help them out.
I
Alright,
can't my notebook.
step 4.
I can't.
Easy step. Y intercepts. Let x equals 0. Now, if you let x equal 0 and g of x, what happens? Well, all the x's go bye-bye, and you're left with what in the top?
Ask that question one more time.
This is your function right here.
Okay.
We can look right here if you want. If I let all the x's equal 0, what's left in the top? 3. What's left in the bottom?
Move your hand.
10. So this is equal to 3 tenths. 0 and 3 tenths. That's our y-intercept. Yay! Now, last step. Step 5. Step 5. Now 5, oops, Jesus. Put it here. 5. This is that number line.
I don't remember doing step 5. I mean step 4.
Step 5 we've done. Step 4 we've done.
He did step 4, he just cut it all out, and just tied a rate.
Gotcha.
Well, it's also easy because you just let x equals 0. They all go away. Because 0 times anything is 0, and then the additive identity kicks in. Alright, number line. What makes the top equal to 0? I'm going to list out the numbers so I get them in order. What makes the top equal to 0?
2 and 5.
No, it does not. That's the bottom.
2 and 5.
She's going way over here. That makes the bottom equal to 0. What makes the top equal to 0?
1 and 0.
1 and
3/4.
3/4. What makes the bottom equal to 0 is the 2 and
2 and
the
5.
5. This is what I'm going to put on my number line. These are the zeros of the top polynomial and the zeros of the bottom polynomial.
Now, hold on.
Alright.
What?
I gotta rate that.
Oh.
Zeros, top,
Zeros, bottom.
bottom.
Alright. Number line?
1, 3/4, 2,
So
and
we're gonna
5.
have
Which is the number that goes the furthest to the left?
3/4. No, yeah, 3/4.
3/4 goes way to the left. What's next?
1,
1. What's next?
2,
2. And then
5.
5. I have seen people put these out of order.
It's possible.
It messes things up horribly.
I bet.
Alright. Pick a number between negative infinity and positive 3/4.
0.
0. It's always the easiest one if you can find it. If I plug in 0,
Now,
We gotta write the
I'm going to write the thing in factored form. The top factors are x minus 1 and 4x minus 3. The bottom factors are
wait,
x minus 2 and x minus 5.
We broke it down so we can use the
where did you get?
Oh, please ask.
Well, no. Let me answer for myself then. Hold on.
This is the top, right?
Yeah, I'm getting
That's a
that.
4x squared minus 7x
Where
plus
did you
3.
get the fact-
Here's 4x. Look, right here, Paul. 4x squared minus 7x plus 3. We factored it into these two.
Right.
All right.
Oh, all right.
Okay. And then the top, or I'm sorry, the bottom part we factored way over here into x minus 2 and x minus 5. Just plug them
It's
in.
not as hard as we trying to make it.
You were trying to make it hard. That's
No,
what's
I'm not
really
trying.
frustrating me.
You try to confuse us.
I ain't trying.
You're at least writing something down for
All
once.
the time.
All right, if I plug in 0 into these 4 factors, what do I get? Well, I get a negative for the first one,
-1.
negative for the second one, and a negative for the third one, and a negative for the last one. For a grand total
It's
of,
always
-4. Positive.
there's 4 negatives, therefore it's going to be a big old
Positive.
positive. Because there's 4 of them, it's even, therefore it's guaranteed to be positive.
it's just
You can prove it for yourself later. Pick a number between 3/4 and 1. Oh, I love this one. Pick a number between 3/4 and 1.
0.
0 is not between 3/4 and 1.
That's 75.
Point what?
7 each.
Dear Lord,
Let
come
me
on.
see, hold on.
How about 0.8?
Point
One.
yeah.
Point 8.
0.8. Point
1 is not between 3/4 and 1 because 1's one of the endpoints. So you're going to let x equal 0.8. Probably the best one you can find.
Sure.
You don't want 0.78 because it gets a little weird. 0.8 is good enough.
Nice whole numbers.
0.8 minus 1. It is not. It's negative. 4 times 0.8 is 3.2. 3.2 minus 3 is positive. 0.8 minus 2, negative. 0.8 minus 5, negative. 3 negatives, negative. Yay.
And I missed
Alright, next one, between 1 and 2. 1.5. Thank God you didn't say a half. I usually get a half. So x equals 1.5. Working with decimals is much better in this situation. Alright, if I use 1.5, the first one becomes positive. The second one becomes,
I'm gonna say negative.
I'm going to guess it's a positive.
Okay.
It's 1.5 more than 4. That keeps it bigger than 3. So that'll be positive. 1.5 minus 2, negative. 1.5 minus 5, negative. 1.5 minus 5. 2 negatives make it big old fat positive. Between 2 and 5.
Let's go with
4, 3, either one works perfectly fine. We'll go for 4. 4 minus 1, positive. 4 times 4 minus 3, that's positive. 4 minus 2, positive. But 4 minus 5 is, and that turns into a big fat,
What in the world is you doing?
a positive, positive, positive. That's positive. Positive times a negative is a odd number of negatives is negative. Even number of negatives is positive. It shouldn't. Bigger than 5.
6.
6. A million. Whatever. So 6. Well, now if you plug in 6, that's positive, 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 and positive. So this last one is positive.
Is it always positive?
No. In my original problem, the one that's actually on my paper, it says negative 4x squared plus 7x minus 3. I multiplied everybody by, and it flips it over. But
Is
they
it
get
all the same?
Then
Is it?
you say when it's a pattern like this, it's called something.
they're all linear factors, so you're going to have a positive alternating.
It's always going to do that.
Only if you have linear factors. Once you have a square in there, things get weird. Like if it was x minus 1 squared on the top.
Is it going to be that?
Oh yeah,
When?
it's possible.
Why would you
They're
do that?
randomly generated. It'll come up every once in a while. So
You
you
don't
gotta
have
Wait, every
go
once in a
through this
while.
whole process
Are
and
you
get
talking
it.
about every once in a while? I'm talking about on the test.
It might show up.
Why
But
would
then
you
you
just
no,
tell
so
us?
you can't. Now, how do
But this method is going to work if you
But
do
it's-
it one way or
we
the
don't know
other.
how, if we've never worked one
Paul,
with
Paul,
one in it,
Paul,
how do we know to do it?
Paul, I'm showing you how to do every single problem by doing these steps exactly the same every single time. This will not change no matter what kind of polynomial function you're dealing with. Ever. You'll get the right answers because you'll have a square here. This will always be positive. The bottom determines whether it's above or below. The answers of this, just because it's alternating here doesn't mean a thing. It's just, it's above the x-axis, it's below the x-axis, it's above, below, and above. For this case. I don't care, we're not going to cover all possible cases, but these steps should rip apart any problem I give you.
So how many of those are going to be able to
All I need is 1.
15 minutes.
It's time for homework.
What? We haven't even finished graphing this.
Oh, we have.
It's only 9:04.
Step 6.
It's time for homework.
We have early release
What?
today.
That's graphic.
You're all insane.
On that.
Alright, graphing.
No, this is still step 5.
This is just graphing. Putting all the steps together in a picture.
Okay.
Biggest number, 5. Biggest number, 5? Yeah. So let's go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4.
And you know what? The night class is gonna even be worse because it's gonna be the end of the day and we're gonna all be tired.
Plus, you get about 2.5 sections a night.
Right, and it's gonna be fast.
Yes, much faster than I'm doing now.
No, it's not.
Yes, it
Oh
is.
gosh, yes it is.
It's not.
Alright, vertical
It's
asymptotes.
not gonna be there. I promise you.
Vertical asymptotes are
Everybody gonna
x is equal to 2
X is equal to 2
And 4.
and 4.
and x is equal to 5.
Way over here. Is he still whining over there? Horizontal asymptote?
Horizontals, y is equal to 0, so you make
No, it is not.
4.
It does say y equals
Vertical asymptotes.
Oh, y equals 4. I was looking
Why
at
are you like arguing with me?
I was looking at the top part.
So y, yeah, make sure you,
Look at the right
Yeah.
area.
okay, so y equals 4 is right about here. It's our horizontal asymptote. Any special points?
Yes.
Not really.
1, 0.
1, 0, which is right here.
And 3/4.
That's a little harder. It's really close to 1. I'm just going to move it over a little bit. I'm going to put it at about half. This is pictorial. This is sketch. I'm just getting points relatively close. All right. There's one more. Actually, there's 2 more.
0 and 3 tenths.
0, 3 tenths. That's like right here. Very hard to draw, but at least get it located above,
That's the.
below the x-axis. Yeah, that's fine. One more point. See, we got the 0, 3 tenths. We got the 1, 0, the 3, 4, 0. This one.
Yeah.
1.84. Now 4 is this horizontal asymptote, so all we have to do is go to 1.8, which is really close to, and go up to the horizontal asymptote and plot a point. So that's 1.8, comma 4. And it's the only point that crosses the horizontal asymptote. These 2 points down here are the only points that cross the x-axis. And the rest of the picture is going to come from above, below.
Yeah.
Alright, so negative infinity all the way up to 3/4, that first dot on the x-axis. Where does this graph have to be? Well, it has to be above the x-axis. That gives you 2 places to be. Either in this lower, below the green and between the blue and the green, not blue, the black and the green line, or above the green line. So, can it be above the green line?
No.
No. To be above the green line, you'd have to go through the horizontal asymptote to reach these 3 points, and it only crosses the horizontal asymptote here. So the only option is, it connects this first point with the second point, and it has to approach that. It stays above the x-axis, and it is approaching the horizontal asymptote, and it's going through the appropriate points that I have plotted. Having points makes it a little bit easier. Okay, between 3/4 and 1, this is the tricky part of the graph. Between the 2 X intercepts, this graph is below, but it has to connect these 2 points. So what kind of shape do you think connects them? A little shiny little curved parabola, something like this maybe. So it comes down below the x-axis. I guarantee you it does not come down very far because those points are really close together. As the points get closer together, the graph just barely goes between them. Now, where does the graph go after 1? Well, it has to go above the x-axis because between 1 and 2 it's positive. And it has to cross through this point on the horizontal asymptote. So the only place to go is
Right
up.
through it.
So go through and finally finish up going towards that vertical asymptote. So you get a weird little
Why
graph
did
like
you
this.
stop? You didn't do between 3 and...
You haven't
Oh, I
gotten
haven't
to
stopped.
that far in the graph yet.
I only got up to 2. So I did between 1 and 2 and it goes to positive infinity.
Okay.
Now we're going to do between 2 and 5. Between 2 and 5, this graph is
Negative.
negative.
Down.
It has to be below the x-axis, but it also has to be gravitating towards both of these vertical asymptotes. So it's going to, be going down that one and be going down that one. And how do I connect them? Something like a
So
parabola.
they are not connected.
Yeah, they are.
I mean, they're not connected to the 1 and 2.
Oh my gosh. No. No. It's just between these vertical asymptotes. They can't go across the vertical asymptotes, and they can't cross the x-axis, so it forces this downwards parabola shape. All right, above positive 5, it has to be positive. Again, it gives you 2 locations it can be in. Can it be in the bottom location? If it is, it would have to go this way. I'm going to kind of dot it in here. This is not part of the graph. But if it goes this way, what is it crossing?
You can't do that.
And it can't do that. And also, it's going negative. So it can't be in this location. It has to be
Above.
up here. It's the only option for it. And those asymptotes are drawing the graph in closer and closer to it. That is a cool picture. That's like one of my favorite ones.
It's weird.
It is weird. I'll give you that.
You need a wife.
Oh, what?
A wife.
Oh, I thought you said a wife. I'm like, I already have one.
You need to take a vacation.
Vacation? We had
Go
one
around
just
the
a couple
world.
weeks ago.
Just go. I mean,
You gonna
leave
take one
North
this summer and
Carolina.
watch
I lived in Hawaii. Where else do I need to
Just
go?
get
Welcome
away,
to me.
travel.
Before you erase that, would you just, no, not that.
Oh,
This other side over here. Somehow along the line, you said